Good afternoon, everyone, and welcome to today's webinar. Today, we're going to be discussing part two of building code basics for historic main streets. Before we get started, I just wanted to go over a couple quick things. First of all, if you missed us yesterday, I will be including a copy of the recording of the webinar from yesterday in the email that I'll be sending out tomorrow to everyone. So you'll get a copy of yesterday's and today's as well. Also, if you are interested in signing up for AIA credits from yesterday, today's continuation, you also need to fill out today's form. So I'll be putting that in the chat box momentarily for everyone to fill out. Um, but before we get started, I just wanted to let everyone know if you have any issues with the webinar software today, just close out the link, re-click the link that was sent to you from Zoom, and that'll solve 99% of the problem. So if it seems like we're being really digitalized or slides don't seem to be moving when Melinda's advancing her slides, just click that link and restart the webinar software. So, with us today, once again, we have Melinda Shaw, who is an architect and COO of Schooley Caldwell, and we have Amanda Fuson, who is a designer with Schooley Caldwell, both experts in building code and architecture and everything else. So, without further ado, I'll let them get their presentation started. Thank you.
Thanks, Devin. Glad everybody can join us again today. This is the second part. So yes, if you missed yesterday or think we're not covering something, feel free to watch the video from yesterday. This is a repeat of the presentation we actually did for the Heritage Ohio Conference back in October. And we had such a good turnout, we decided to do it again. So this is going to cover anything, well, a lot of things with historic buildings that you may have in your typical Main Street Ohio communities, and looking at different code improvements that may be required, what you do need to do, what you don't, and a few examples of why the building code is the way it is, because I honestly find that fascinating, and looking at all sorts of case studies as to why we are where we are. So, a few learning objectives that we have to include. Anyone that's used to submitting for AIA continuing education credit is used to these. So, all five of them. So far, yesterday we covered why we have building codes, what the building code is, where to start when you have a building, what construction types are, what use types are, and what it means for a building to be up to code. So then we are moving on now to common issues we find in buildings. So.
Yeah, so what are some of the common issues in existing buildings? Well, yesterday, as Melinda mentioned, we talked a lot about construction types and the use of a building and how together they can dictate how tall and large you can construct. And this was actually a question posed yesterday. Can I have more than one use within a building, within an existing building? And the answer is definitely yes. And more often than not, that is actually the case on most of our projects. So on the right is actually an example. This is Levesque Tower downtown, and it has a hotel, residential, restaurants, bars, like anything, the office, anything you can think, all within the same building. But if we remember, occupancy helps us determine how people will move through a space and evacuate a space. So what happens when you have adjacent occupancies like this? Well, depending on the occupancy types, a rated separation would be required. So if a historic building were to remain mercantile on the first floor and offices above, no separation would be required. And you can see on that table on the left that business, B for business, and M for mercantile, they're actually grouped together. So they're never required to be separated. However, any business, office, or retail space mixed with residential would require a 1 to 2 hour separation depending on whether or not it's sprinklered. And you can see where those two converge on the table, telling you the rating that would be required. And the purpose of this is that, as previously discussed, people function differently in different uses, and you might have people more or less familiar with the building. So in a retail environment, or you might have people, going to work in the same building every day, taking the same stairs every day. But you might also have people in a residential environment, like a hotel, that have never been in the building before. And again, the point is that a fire within one use group should be contained within itself, not spread to each other. And each use will have different egressing requirements. So the gist is that oftentimes you do have to separate these uses. Moving on, some other complications we see in existing buildings as it relates to code are restaurants. So unless you have an occupant load less than 50, again, that magic number 49, they are usually considered an assembly space, which means two means of egress and exits are required. Those exits have to have panic hardware, and these spaces are required to be sprinklered, and you would have to have a separation between this and any other use group. However, like I said, if you calculated the occupancy and it is less than 50, it would actually be classified as business, and a lot of those requirements would go away. But another issue with these restaurants are commercial kitchens. They still must meet regulations, modern regulations. And so what that means, you have to have kitchen hoods, which are required to maintain air quality and remove particles. And those hoods have to have a fire suppression system. And there are also very specific space requirements with kitchens, with contemporary commercial kitchens, that if you think about a lot of times in these historic buildings, they were never designed, even if they were a kitchen, they were never designed with the clearances that are required today. So it's always something to consider in historic buildings, how you can make it work with modern clearances within these really tight spaces. Moving on, another issue that we often see in historic buildings is that they have these beautiful, open, monumental stairs connecting multiple floors, and these are essentially just chimneys. A lot of the reasons in some of the case studies that we've looked at in the fire tragedies were open stairs that didn't protect people evacuating buildings. And really the purpose of egress stairs today is to provide that safe path of egress from a building under fire conditions. But, we have these beautiful historic stairs. So when are you allowed to have them? Well, in new construction, they're allowed whenever they're connecting or within a single story, where they only connect 2 stories. They're allowed within atrium spaces, and they're allowed in, say, a movie theater balconies that's connecting to a movie theater balcony. Those are just a few examples. And in adaptive reuse, which is what we're talking about on existing buildings, they are allowed when there's no change of use within the building, and if there's another compliant stair otherwise provided. So the example on the right is actually from Perry County Courthouse, and it has this beautiful historic stair connecting multiple floors, more than 2 floors. And in this renovation, we were not changing the use of the building. It was a courthouse. It's going to remain a courthouse. It has assembly space mixed with office, but because we provided an additional compliant enclosed egress stair, we were allowed to keep this beautiful and restore this beautiful stair. Then I think we're moving on to sprinklers.
Sprinklers. Yeah, so sprinklers are one of those things people are like, oh, do I really need to add them? What if they leak? What happens? What if they flood my whole building? But there's a few things to keep in mind. So first of all, sprinklers do not extinguish fires. They also don't get activated by pulling the fire alarm. And if there is a fire, only the sprinkler where the fire goes off. It is not the movies. So this is an image of what happens in the movies. You have a little fire on one spot, all the sprinklers go off. That is not how they work in reality. So in reality, when a sprinkler goes off, it is designed to suppress a fire or reduce its spreading. They're designed to give the occupants that are in a building time to get out, and for the firefighters to arrive and fight with the fire. So they're also intended to help limit smoke damage, limit fire damage, and they're actually activated by heat, not by the fire alarm. So there's actually this little glass plug in them that is designed to melt at a certain temperature and because of the liquid that's in it. So once it heats up to a certain temperature, it bursts, and that allows the water to flow through, which is why it only turns on that one head, not all of them. So it actually uses less water than fighting using a firefighter hose. Um, and one thing to think about if you're debating whether or not to add them, they really do help reduce insurance premiums, and they help with code requirements for most use types. So it can be a big savings. You know, adding in sprinklers can be help you trade off on something else that maybe is not meeting current codes. So generally, if you have a building that has sprinklers, for each use type, they are allowed, that building can be 10 to 20 feet taller if the building is sprinklered than if it's not. So if you have a building that is fairly tall, and you're changing its use type and need to make sure you can get occupancy for it, adding sprinklers can be really helpful because you're not going to go and make those stories shorter. Likewise, for nearly all building and use types, if you have sprinklers, that building can be 1 story taller than it would before. This is also really helpful when working on old buildings that maybe were 3 or 4 stories tall, but under the current code provisions with that use type and that both use type and construction type would be required to be shorter than maybe what it is. They're also really helpful if you have, going back to that question about can you have multiple occupancies within one building? If you are trying to get a separation between occupancies, sprinklers can also help you with that. Instead of maybe needing a 2-hour separation, it takes it down to a 1-hour separation. Sometimes it can even get rid of your separation completely. So, it doesn't work on all of them, but it does help with a lot of them. It can also help you with your areas of refuge. So an area of refuge is basically a place in the building for someone that to go and wait for the fire department to come and rescue them, the first responders, if they cannot use the stairs to get themselves out of the building. If you have an automatic sprinkler system, generally these areas are not required. So if you have a tight building with tight stairwells that is not sprinklered, you're going to have to find a way to make that stairwell or add areas of refuge into the building, which in a tight footprint, again, can be hard to do. There's also other things that go along with it. You need to be able to call and let someone know where you are. And so there's communication requirements in there as well. And looking at travel distance, how far can you go to get out of a building or get into a safe enclosure in a building? That is also a greater distance if you have sprinklers, which if you think about it, makes sense. The sprinklers are helping to control the spread of the fire. They're helping reduce the smoke. Therefore, it makes it safer for the occupants of the building to have to walk a little farther to get out of the building. Likewise, corridors. Dead-end corridors are a common problem in old buildings. If you don't have sprinklers in your building, generally speaking, your corridors cannot exceed 20 feet in length to a dead end, meaning and that does not lead to a stairwell. If you have, for most occupancies though, if you sprinkler that building, all of a sudden you're allowed up to 50 feet from your last point of where the stairs are to the end of your corridor, which can really help with your trying to locate new stairways in a building or just bring existing stairways into compliance, because oftentimes they're closer to the center core of a building than they are in newer buildings. So, example of why sprinklers are so important. So in 2003, there was a Station nightclub fire. This was a building that was multiple adaptive reuse. It was originally built to be a gin mill, then it was converted to a restaurant, and it even had an earlier fire in 1972, and that caused significant damage. They addressed some of it, not all of it. In 2002, there's revealed to be 9 different code violations. but they missed one of the other big ones. It had no sprinklers and no fire department connection. It also had, although it had 4 exits, they had a very narrow hallway leading to the entrance. So unfortunately, when there was a stage show, there was a pyrotechnics display that ignited the flammable acoustic foam. Um, the fire began within 9 seconds of the pyrotechnic display, so very quickly. The entire building was engulfed in flames within 6 minutes. And if you can imagine a packed nightclub, this is people who don't know the building that well. They don't know where all the exits are that well. They only know the one narrow hallway they came in on. 6 minutes is not enough time to get people out. Over 100 people were killed and 230 people injured on a lot of it, some of it smoke, some of it fire, also just by the crowd crush, meaning so all those people trying to get out that one small entrance. This resulted very quickly in Rhode Island changing their fire code so that every nightclub with over a certain capacity has over 150 people has to have a sprinkler system installed, because that would have helped slow this, even if it didn't put out the fire, because that's not what sprinklers really do. It would have slowed down the fire enough to get people out of the building. So we don't necessarily have that law in Ohio, but it's still a good thing to learn from. So going back to our 101 Main Street buildings in Somewhere, Ohio, that we saw quite a few times yesterday, which is kind of your typical 3-story Main Street building downtown. If we assume it is 36 feet tall, it has 3 floors. It's a construction type 3B, which, as Amanda mentioned yesterday, is considered ordinary construction. It is okay height-wise. So it falls right in here, no problem. And so doesn't necessarily have to have sprinklers. But it does need a 2-hour rating between the first and second floor. But we can also, if we change to restaurant and things like that, you may need to add sprinklers. It also allows, adding sprinklers allows us to go from having a 2-hour rating between these two uses to a 1-hour rating. 1-hour rating is much easier to achieve. Also, sprinklers in restaurants generally just a nice added bonus. So moving on to getting people out.
So we touched a little bit yesterday about the fact that construction type and occupancy classification affect egress requirements. So now we're going to dig into a little bit about what those are. So again, reiterating yesterday, for adaptive reuse projects, our construction type is an existing condition. So that, in conjunction with what occupancy we want to put in the building, will determine the egress requirements by code. So we're going to get into, like, when do I need 2 exits in an existing building? Next slide. Yeah. So the answer goes back to the occupant load, which we touched briefly on yesterday. And again, this is the idea that the code has already determined the amount of square footage allocated for, or that each occupant needs, depending on the use. So for example, you can see on the table on the right highlighted, for business and offices, that's 100 square feet. For retail or mercantile, that's going to be 60 square feet. And those numbers, the 60, 100, those are called the load factor. So for a new build, a client might say, I want a new building that that holds X number of people, but in existing buildings, the number of occupants allowed is determined by the existing square footage and the desired use. So using our Main Street building as an example, let's say it's 3,000 square feet per floor, with restaurant on the, or retail on the bottom in this case, and business on top. 3,000 divided by 60 gives us 50 occupants on the ground floor. And then you can see how it's divided to give us 30 occupants on the second and third floor. And it gives us a total occupant, or 110 total occupants on this floor, or on this building. So Once we've determined the occupancy load per floor, we can determine the number of exits required. So for occupancy types, mercantile and business, an occupant load exceeding 49 people requires more than 2 exits. And that's highlighted on the right at the table. For our building, that is the case. We do have more than 49 people, more than 50 people, and that would require at least 2 exits for our building. And additionally, the occupancy type will determine the maximum distance that an occupant can travel to reach one of those 2 exits. So if you go to the next slide, so the distance to the exits and also the location of those exits. So the first factor of this is that I'm allowed to travel. How far am I allowed to travel to get to those exits? On the right table, you see for assembly, educational, and mercantile, the maximum that I can ever be from an exit is 75 feet, even with the sprinkler system. For business, it's also 75 feet, unless I have a sprinkler system, in which case it jumps up to 100. So that's an added benefit because you can have greater distance to your exits because you're adding that extra layer of protection, as Melinda discussed, to help people move out of the building. Another thing that the code dictates is that if it tells me I need 2 exits, I can't just put them anywhere in my building. You can see the floor plan diagram on the left. I can't have them right next to each other. Say there was a fire in the back, or say there was a fire right in front of those 2 exits and I'm on the back end of that building, both of my exits are compromised, and that's not going to, people won't be able to evacuate the building. So they're actually required to be located no less than half the overall dimension of the building apart. And that's what you see on the diagram on the right, is that I have 2 exits determined by my occupant load, and they are the appropriate distance apart to ensure that if one is compromised, people can still get to the next. And lastly, for exits, the path of egress cannot pass through rooms that are locked, kitchens, storage rooms, closets, and that makes a lot of sense. You don't want people egressing through any rooms that are locked, or you don't want them egressing through more hazardous conditions that than they're coming from as well. So another code requirement, and Melinda talked about this briefly in her case study example of the nightclub fire, is specifically for assembly space. If you have an occupant load greater than 300 people, the main exit from that space has to have the capacity to accommodate at least half of that occupant load. And this is because big crowds in emergency situations in assembly spaces, they're more inclined to leave using the exit that they arrived in. If you're unfamiliar with the space, you're going to exit through the corridor and the door that you came in. So that is why the code requires with this many occupants that you have greater capacity for that main exit. And the main exit essentially has to be able to accommodate the total required capacity of all means of egress leading to that exit. So the theater floor, the concessions, all converging at that main exit. There's also a 10-foot width requirement as you exit this door on the exit side of the door. So the code doesn't want people who are still trying to exit the building being hindered by people who have already exited. So leaving room on the outside for the convergence of those people. So back to our case study building, located in Somewhere, Ohio, that is type 3B with a mixed business and mercantile use. You can already start to tell how the occupancy classification impacts how I can renovate my building. So for our example, it can't exceed 70 feet in height. So that's something to consider when you're thinking about additions. At 9,000 square feet, sprinklers are not required since it's less than 12,000, although it's always a good idea, and you can see that it has code implications if you do. The occupant load, which was established by how much square footage you need per person, and business and mercantile is 110, triggering the need for 2 exits. And we know that based on an unsprinklered building in this use group, our exits can never be more than 75 feet apart. So another one of our case study examples is the 1946 Wynkoff Hotel fire, which happened in 1946. This building was touted as being completely fireproof. It was 15 stories tall, had 2 elevators. However, it only had one unenclosed stair. And we touched briefly on the ramifications of unenclosed stairs connecting multiple floors. They're essentially chimneys and do nothing to protect people during evacuation, no matter how otherwise fireproof your building is. This building also had no automatic sprinkler system, which would have been required today. And the corridor walls were finished with burlap fabric, which is incredibly flammable. And it compromised the integrity of those egress corridors. So while the structure may have been fireproof, quote unquote, they covered all of those egress corridors with a really flammable material. Like a lot of historic buildings, it also had operable transoms above all of the hotel guest rooms into the corridor. And this was it was a common practice to allow airflow in and out of the rooms. But the consequences of this, a mattress caught on fire on the 3rd floor, so a really low floor, and everyone on the floors above weren't able to evacuate in time. And you can see, the burlap caused the spread of the fire or increased the spread of the fire. And those operable transoms actually allowed air in and fueled the fire in the corridors. And unfortunately, 119 people died in total. But the results, so what changed? So the building exits code, which was renamed to the Code for Safety to Life from Fire, was significantly revised in 1948 to address the issues of finish combustibility. So the issue here wasn't the structure, it was about the finishes within these rated corridors. And this fire also led to the incorporation of wartime research into the flammability of building materials, and into code requirements and design standards.
Yeah. This is another crazy example similar to the Triangle Shirtwaist Factory building, that this building had this huge tragedy. This building is still standing, and it is still a hotel, so you can go stay there still. Hopefully they have fixed a lot of the other issues since then, so I'm not sure if I'm ready to stay there or not. But so accessibility, this is another question we frequently get from people when they're starting to look at their historic buildings. It's like, well, how much do I need to do? Do I need to do anything? And what governs accessibility? So accessibility in Ohio is actually governed by 2 different things. There's ADA, which is what everyone normally thinks of, which is actually a civil rights law, not a building code, that prohibits discrimination against individuals with disabilities. So that kind of defines what you like, that you're not allowed to discriminate against people. But then ICC A117.1, which is a mouthful, is the standard for accessible and usable buildings and facilities. This is the reference standards for the technical provision. So this is the book that is actually referenced by the building code, and it tells how things are supposed to be done. So diving into the 2 of those, and they often overlap. Generally now they are in agreement with each other, which helps. For an existing building, what it comes down to is if it is for the public, especially if it's for transportation or just generally, you should, depending on how much money you're spending on the building, if you're making significant upgrades, you need to make sure that the public all of the public can have access to all the main areas, which means, if it's business or retail, having restaurants having access to all those, also everyone that has access into the building needs access to a bathroom, to the telephones, to the drinking fountains, elevators, if there are any. They need to have access to the path of travel, all those critical areas. So breaking those down a little bit. So what it talks about is owners of places of public accommodation are responsible for readily achievable barrier removal. And they have actually identified a priority for those. So assuming, if you can't do everything, you need to be able to get from the public sidewalks, parking, or say the bus stop into the building. Makes sense? Doesn't do you any good whatsoever to have an accessible restroom if you can't get into the building. Once you're in the building, you need access to where goods and services are available to the public. Again, makes sense. That's the next thing you're going to come across coming into a building. Then you need access to restroom facilities. Again, this is a basic thing that all people need access to. And after that, you need access to the goods, services, facilities, privileges, advantages, accommodations of a place of accommodation. So after that, you're looking at access to pretty much everything else. There are still some exceptions for, like in a theater, you wouldn't necessarily need access to the projection booth or to the catwalks above the stage. But trying to get everyone to be able to get to all the public places of a building. So barrier removals includes installing ramps, widening doorways, rearranging shelves and furniture. This comes into play a lot with libraries that may have originally had very tight, narrow aisles, and making sure door hardware is accessible. So this is actually a picture of Slocum Hall, which is at Ohio Wesleyan. When we started working on the building, despite the admissions department being here, it did not have an accessible entrance to the building. The front doors were up a couple steps, and even if you managed to get up a few steps to that portico, then from the portico into the building was one more step at the doors. So working with the university, we were able to incorporate a ramp off to the side, and we actually raised level of the landing so it was flush with the interior as well. So that way it takes care of that first level of barrier removal, priority number one. So readily achievable, that means what can you easily accomplish, what can be carried out without much difficulty or expense. And this kind of comes down to how much are you doing to the building. If you're spending $20 million to update the building, then yeah, you better be making some accommodations. If you only have $5,000 that you're spending on doing updates to the building, it's going to be a different standard. But the factors that come into that are the nature and cost of the action needed. Is it a simple wood ramp, or do you need to put in an elevator? The overall financial resources of the site and company. So if you're a mega corporation, Fortune 500, and you're like, well, I just don't want to spend the money on it, that's not going to fly. The number of people employed at the site. If this is a building that only 4 people come to, or either work there or come to visit very often, is a very different standard than if you have a downtown high rise that has 500 or more people working in it. And then also what type of operation. Is this a building that the public isn't really going to come to, say, for example, a production greenhouse? Or is this a courthouse where all of the public needs to be able to come for their rights to be at court? So looking at removing other barriers. So door openings must be at least 32 inches clear when open 90 degrees. So as architects, that often means we're on the assumption that all doors need to be 36 inches wide. The door leaf needs to be 36 inches wide because that gives us a little wiggle room. But really what the 32 inches clear means is you need 32 inches between the face of the door when it is standing open 90 degrees and the inner stop of the jamb on the opposite side of the door. Um, there are some tips and tricks you can do if you have doors that are slightly narrower than what this is. You can change to wide throw hinges, which can allow you to keep your existing door and door opening. It's a lot easier to change out a hinge than it is to change out a door opening. Um, and a few other things as well. Um, Also, this applies to pocket doors, which are a little tricky. And then it also um, starts to come into play if you have openings in walls that don't have doors, but are just openings, especially if they are in a thicker wall that you would often find and our older 3B type buildings that love their thick masonry load-bearing walls. So when it comes down to doors, doors have lots of different clearances required at them. So depending on how you're approaching the door, if you're from the latch side, the hinge side, the pull side, the push side, um, every different direction has different clearances. And they are also impacted if your door has a closer on it, one of those things that automatically keeps your door closed, like a fire egress door should. You need a little more wiggle room, which if you think about it, if you have to hold the door open because otherwise it closes on you, that is a different task and activity than a door just you manage to get it open, you can go through and then close it. So generally, um, well, there is no general when it comes to doors. They all require a lot of different clearances. So when in doubt, look it up. For ramps, ramps are one of the big interventions we do in buildings. And the great thing about ramps is they're not just for people in wheelchairs. They are also for people that have other mobility challenges, whether they are using a walker, a cane. It's just hard for them to go up steps, as well as people at other points in their life that maybe you're just on crutches because you have temporarily, or if you're pushing a stroller, strollers don't like going up steps any more than wheelchairs do. So ramps really are great for everyone. Um, Generally, if you need to add a ramp needs to have a maximum slope of 1 to 12. That means for every inch you have to go up, it has to go out 12 inches. So 1 foot, 1 inch up, 1 foot out. Um, if it's an existing building, you can have a ramp with a rise of up to 6 inches with a slightly steeper slope of 1 to 10. So again, for similar idea, if you have an existing building that has a ramp with a rise of up to 3 inches, you can make it even a little bit steeper of 1 to 8. Um, and the reason that these vary, they've working with different groups, realization that, if you don't have to go up as high, you may have the energy to go up a ramp that is slightly steeper. But if a ramp is much taller than 6 inches, it requires a fair amount of effort for someone to make it up it. So it needs to be a more gentle slope. Um, any ramp that has a rise of 6 inches or more, it must have handrails on it. So both to aid people going up the ramp, either wheelchairs, people just other mobility problems. So plus it's starting to get taller and you want people not to fall off your ramp. So, but there are lots of different ways to incorporate ramps. It just requires some creative thinking. So then looking at restrooms, so it's that next level of accommodation. Once you get people into your building, once people can use the public space, they also need to be allowed to use the restroom. So restrooms have very, very specific clearances, and a lot of them. The toilet has clearances, the door has clearances, the sink has clearances. Everything in a restroom has specific clearances, and it really does take some time to walk through, double checking that there is room for everything in a bathroom, and there are some clearances that can overlap, there are some that can't. Generally speaking, you need to have room for a 60-inch turning radius. Now, this is recently updated in the newer building codes that came out to be even larger because wheelchairs and people have gotten larger. So in some locations that dimension actually is bigger than that. You're also required to have both horizontal grab bars and now vertical grab bars in restrooms. And the other thing that these diagrams aren't showing is toilet paper dispensers and things also have to be within a certain distance. So following those same guidelines, restroom stalls have all sorts of clearance requirements as well. There's your more typical stall that traditionally was 5 feet square, 60 inches square. That is what most people consider, your accessible toilet compartment. Depending on the size of your building and how much you're able to alter it. There are some alternative stall configurations that you can look at that are outlined both in A117 and in ADA. And then depending on the size of the stall or the size of the restroom and how many stalls you have, you may actually need to also add what's considered an ambulatory compartment. So this is a toilet compartment that's a little wider than a typical one, but narrower than the ones that's designed for wheelchairs, but it's designed with grab bars on both sides. So this is intended for people that are mobile, can have get around, but they may need help standing back up. So that's why the grab bars on both sides, so you can pull yourself back up. Those are really kind of serving two different groups of people. So elevators. This question came up yesterday. So we promised we would get to it today. So when do you need to add an elevator? So again, the when part is covered by ADA. You need to add an elevator if your building is over 3 stories and or more than 3,000 square feet per floor, or if it is a shopping center or a mall, a healthcare provider, public transit, or an airport. So, and the reasoning behind those specific uses, if you think about it, a doctor's office, that's more likely to have people with mobility challenges coming to it. You need to make sure people can get to their doctor. A shopping center or mall is a big public area that everybody needs to be able to go everywhere in the mall. Same thing with public transit and airports. Those are very public facilities. People need to have access to everything. So what that means is if we take our Main Street building and shrink it down so it's only 2 stories and we have retail on one floor, offices on the other, and it's just generic business office, not a doctor's office, and it's only 2,000 square feet per floor, you would not be required to add an elevator. Now, if you have that same building, same footprint, but all of a sudden a doctor's office wants to move into the upper floor, at that point you would need to look at adding an elevator. Now, it wouldn't necessarily have to be a full regular elevator. Sometimes, especially in older buildings, you can look at what's called a LULA, a limited use, limited access elevator, as an option to provide accessible route to that upper floor. And then if we get back to our regular Main Street building that's 3 stories, again, it's now 3 stories, so an elevator is required. And elevators, even once you do add them, have different size requirements depending on how tall your building is. If it's over a certain height, you need to be able to accommodate a stretcher. Otherwise, generally, if you notice, they're kind of similar to toilet stalls in terms of dimensions. You have to be able to get someone in there and turned around. So energy efficiency, part of the building code does deal with energy efficiency. There is an International Energy Conservation Code that is part of that big stack of code books that we talked about yesterday. So generally, the Energy Code establishes the minimum energy standards for new and renovated buildings. There's lots of different ways to achieve this. There are a lot of leeways for older buildings, and really what you're going to have to do is sit down and start looking at what makes sense to do in your building, what doesn't, especially if you have masonry walls. We have to be careful about adding insulation to them because the last thing you want to do is add all this insulation and then cause dew point problems, which can cause mold to grow. That is not going to do anyone any favors. Eventually, in most jurisdictions around Ohio, to show that you are compliant with the energy code when you go to pull your building permit, you can either do energy modeling, which requires complex software, or there's also something called ComCheck Web, which allows you to kind of put in the size of your building, what the walls are made out of, and it will start doing a lot of those calculations for you. It's pretty useful, especially in smaller buildings. So a few simpler energy improvements. So easy improvements, storm windows for historic buildings. If you add a storm window to a historic window that is otherwise just a single piece of glass, you are going to get about the same U value as you would if you replace that window with an insulated pane of glass. But in this case, you've one, saved a bunch of money, and two, you've saved your historic windows in their appearance. Other easier improvements is adding roof insulation, and that can really make a big difference in how your building functions. Looking at energy efficient light fixtures, motion sensors, and water efficient plumbing fixtures are all fairly easy things to do. If you start getting into bigger renovations, you can look at insulating the exterior walls, though again, that's something you need to be very careful about. Same thing with if you have a slate roof. Slates need to breathe. Absolutely contact a professional before you insulate a slate roof, because you do not want to cause damage to a roof that is otherwise a very long-lasting roof. Heating and cooling systems, as they are updated, there are more energy efficient options out there, as well as solar panels and geothermal systems. And the National Park Service has recently updated all their guidelines for solar panels and geothermal and have a lot more information and guidance on newer systems out there than what they used to have. So, which has been really helpful. So back to our case study building. So looking at our building, one scenario, we have a restaurant with offices above. Next option, we have a restaurant with offices and then an event space. And scenario 3, it is retail with offices and apartments. And looking at all these different uses, where do you need to add separation, which is what Amanda started talking on earlier. So going back and forth between them, basically what it comes down to is restaurants, because it's an assembly space, need to be separated from pretty much anything else, other use. So it has to be separated from your office space. Now, if scenario 2 has a restaurant on the first floor and event space on the third floor, event space is also considered an assembly space, so it needs to be separated from your office space as well. So at that point, you have rated assemblies between your restaurant, between both your first and second floors and your second and third floors. Then scenario 3, if you remember, mercantile and office don't necessarily need to be separated, but office to apartments do. And that's because the apartments can have people sleeping in them. So you want to make sure fire isn't spreading to an area where people may be sleeping. So this is the chart that is in the building code. It's table 508.4, which is one we reference a lot. And this goes over all the different separations that you may need, depending on if it's sprinklered or not and what your different occupancy types are. There's another chart in section 504 that talks about how many stories your building can be. So looking at this chart, if we know that this is our 3B building and we're looking at an assembly type, we need to be careful that it's and watch that it's 2 to 3 stories. If you notice that there's not many, not really any uses for assembly that can go above 2 or 3 stories, even if it's sprinklered, which means if you have that building and you want to add a rooftop patio so you can have outdoor bar or something on it, that's unlikely to be allowed under the current code. So. Then resources. No one memorizes the building code, even architects. So these are, for those who are joined us yesterday, these are a lot of the same resources Amanda went over yesterday, just so you have the links and know where to get them. The National Park Service, in addition to Brief 51 about building codes, as I mentioned, does have other ones about energy efficiency and accessibility. They're really, and they have been starting to update them in the last year or two, and they have planned updates for several more over the next 2 years. So, which will be great and exciting to see. So. With that, Devin, any questions?
All right, we got one question already, but please type in your questions now if you have them. I'm also going to put back in the chat box the link once again for signing up for AIA credits for part two of the two-part webinar series. Just to make sure everyone remembers, you need to attend both sessions or watch yesterday's recording in order to receive credit for these. So, Melinda, the first question we have here is a lot of times, you hear developers in particular talk about the unimportance of sprinklers. And I've heard this line a couple times actually myself of sprinklers have never saved anyone's life. So would you like to comment on that?
I would say that's probably absolutely wrong. They, you know, they very much slow down fires. There is a reason the building code relies on them so heavily. If that hadn't been proven so many times, or the building code would not have been changed to allow all those provisions. And this these two webinars don't get into the existing building code because that's several hours all on its own. But that gets into a lot more, even more allowances than what the regular building code does. So uh, I get why they don't want to put them in. They're expensive, but they absolutely do save lives. They help give people time to get out of a building. So,
Thanks, Belinda. Next
yep.
question here is, do you happen to know the latest guidance on bathrooms in relation to gender neutral options?
Oh, geez, it keeps going back and forth. When in doubt, build unisex restrooms that anyone can use. Then you can just change the signs on them. And especially if you go, it's kind of fun anymore. Sometimes you see memes and things come across that like different signage options that people have gotten very creative on their signage for bathrooms. In Ohio, I know the legislature was getting involved for better or worse. One about restrictions in schools and what was going to be allowed and what wasn't. Generally, if a room bathroom is a standalone bathroom that anyone can use it, if as many of those as you can incorporate as possible, they're flexible and anyone can use it no matter what their gender preference is. So it's hard.
Next question here is, can you comment a little bit on how elevators can work sympathetically with the interior standards or the standards from the Secretary of the Interior?
Yeah, so we have the fun job of I have incorporated elevators into historic buildings several times into places where they're either Slocum Hall, which is actually, let's see, well, it doesn't want to advance for me. Um, is that building that didn't have an accessible entrance had never had an elevator in it either in 120 years of its existence. It's all about finding the right location. And that is a balance between finding a location that makes sense with the circulation, but also not putting it smack down in the middle of a courthouse rotunda, which no joke we have seen before because they're like, oh, there's already a hole there. That's an easy place to put an elevator. It's like, just because it's easy doesn't mean it's the right place. Type 3 buildings often actually aren't that hard to build a new elevator shaft in because you're dealing with cutting through wood floors that you can fairly easily resupport on your new concrete block shaft wall. So in some ways, I would say it's easier to put an elevator in that type of building than it is um, working on one right now that is a post-tension concrete building. That is a whole different ball game trying to cut through. So it really is back and forth. You have to kind of look at where it goes. Where does it make sense for circulation? Earlier on that elevator slide, the elevator that I showed is actually one at Franklin Park Conservatory that we added inside a greenhouse. So, it is a glass and steel elevator because it would not make sense to build a concrete block elevator in the center of a building that is nothing but steel and glass. So it just takes time and, some design thought, but it can be done. I haven't met an elevator or a building that we haven't been able to add an elevator to. Can you think of any, Amanda? I mean,
No,
I was gonna say we moved
not
it
a.
in the arcade had put one, the Newark arcade had put one in a terribly awkward spot, and we actually moved it
Mhm.
because the elevator was no longer functional. It was just in a horrible location for multiple reasons. So um, if you want to put an elevator in a building, you absolutely can. It's just a matter of thinking carefully where you're
Mhm.
running it.
Thanks again. Next question here is how does being unoccupied for a period of time change the code requirements for renovation?
Um, so that somewhat depends on your authority having jurisdiction, your local building department. If the building never really lost its occupancy permit, then you should still be able to um, go back to the occupancy that it originally had. If as long as no one had, if it was a theater that had gone unused and all the seats had been removed and a bunch of other modifications, it's going to be hard to say that there had been no change in use. If it was just, one of your Main Street buildings that had old office space on the upper floors and had just been not used for the last 20 years, but no changes really made to it, that's a different story. It's still that occupancy type. You haven't made any negative improvements to it. So I recommend sitting down with your AHJ early in the process. I know we did that big shout out to the Licking County Building Department who's been working with us on the Newark Arcade. They've been absolutely wonderful. Been talking to him for nearly 5 years now, trying to get that project done. And we sat down early and talked about code considerations. Do you consider this a change in use? What do you not consider a change in use? What do we need to do? So just have those conversations early on because they really can make a big impact on what you need to do to your building.
Here's an interesting question for you. How do you find people to refurbish public art, such as the Ohio Judicial Center?
Oh yeah, we showed the ramp from that earlier. So it depends what the art is. There, sculptures are one thing, uh, public murals, paintings are another. We've gradually kind of developed a list of artisans in Ohio. If it's in a public building, it's part of a bigger project. The work is publicly bid. We've worked on developing specifications that require people to have a certain amount of experience. I would definitely say it never hurts to reach out to other local architects in that area that keep those lists. The SHPO's office probably also knows some of them. So it's hard because there's not one company that is good at doing all of it. There are some that are really good at murals but won't touch a zinc sculpture. So it, it's that's a hard one. I don't think there's one great place to look for all of them, but
All right, last chance to ask questions. We'll give you a moment to type those in. Once again, I'd like to thank both Melinda and Amanda and Schooley Caldwell for putting together this presentation for us, both for at our conference last year and over the last 2 days. And a reminder to everyone, if you haven't filled out your AIA form, now is the time to do it before the link disappears in the chat box. I'll get those sent out to people over the next few days. As mentioned at the beginning of the webinar, I will upload this recording this afternoon, and then you should all be receiving an email that has both yesterday and today's recordings links in there. More than likely, I'll send that out later this evening, but it might be tomorrow morning as well. Not seeing any more questions, so thanks again, everyone, for attending. I'm Linda. Amanda, do you have any final comments before we sign off?
no, thanks for joining us and
Yeah.
talking about the building code. So
Yeah. Thank you.
All right, thanks, everyone. Have a good day. We'll see you at our next webinar. Thank you.